This video is going to take a closer look at parabolas. And as you begin to graph functions over the years, you will find that there are different ways that we can express them. And in expressing them different ways, we can gather different information. So that's primarily what we're going to look at tonight. You should be on the perplexing parabola problems in your notes. And actually, I would like you to do the first half of that page on your own, up to where it says the vertex form of a parabola is, and it has a box. Okay, so we have talked about the standard form of the equation of a parabola, which is ax squared plus bx plus c equals 0. We have also talked about what happens as we change different constraints within that equation. And if a is greater than 0, the parabola opens upward, which means that I have a minimum value. If the a is less than 0, the parabola opens downward, which means I have a maximum value. To find the vertex of the parabola from the standard equation, I use the formula x equals negative b over 2a to get my x value, and then I just plug back in to get my y value. The axis of symmetry is in fact x equals negative b over 2a, and the y-intercept then is c. What we are going to look at more closely is the vertex form of the parabola. Now, the vertex form is exactly that. It gives you the vertex. And this is going to look a little strange, and we will see why this is so. Now, remember that first day when we talked about these equations, I talked about the whole HK thing. HK is very significant when graphing different conic sections, and a parabola is one type of conic section. We will talk about why that's a conic section also, but HK is typically your center, your vertex. It kind of has significance in all types of graphs. And what we can see here is this would automatically give me what the vertex is. It is HK. To write an equation given the graph, you can use that vertex form. Sometimes you'll be given a graph and it'll say write the equation of the parabola. Well, you might not be able to see the roots. In this case you can, but you might not be able to see the roots, and then you wouldn't be able to write that equation as easily as we've been doing it up until this point. So my vertex is 3, negative 4. Now I'm going to plug that into the formula. I don't know what a is. I know that my x coordinate is 3 and my y coordinate is negative 4, so I'm just going to write minus 4 here. And I'm going to pick a point and solve for a. Try to pick an easy point. In this case, I'm just going to use 5, 0. I could use 0, 5. I could use 1, 0. I could use 6, 5. Okay, any point, it doesn't really matter. And I'm going to plug that in for my x and my y. So I'm using the point 5, 0. So that's going to be 0 equals a times 5 minus 3 squared minus 4. And then I just go ahead and I solve for a. So why don't you go ahead and do that and tell me what you get? I got a equals 1. So now I can write the equation of my parabola y equals 1 times the quantity x minus 3 squared minus 4. I could then transfer that to standard form just by simplifying everything. You can go ahead and do that on your own. It's x squared minus 6x plus 5, y equals there. We have several examples on the next page for you to work on, and I will write the answers and you can come back and check. There is something else I would like you to think about while we are on this topic, and that is, why do I have this equation for my axis of symmetry? I told you this a couple days ago. Do you believe me? Can you prove it? And now that you have this particular equation, you can prove it. It's a little challenging, but maybe you might want to think about that. In the meantime, you can work on the problems converting the equations from standard to vertex form. So let's take a look at this sheet starting with question number 1. And what they would like you to do is convert the equations from standard form to vertex form so that you can find the vertex of the parabola. In the first case, it's easily factorable. And if you go ahead and factor that equation, you get y equals the quantity x plus 1 times the quantity x plus 1. And hopefully here you're seeing a little connection and saying, aha, oh, I see. That's y equals quantity x plus 1 squared. Perfect. And what that means is my vertex is going to be -1, 0. Okay, because I don't have my hk, my k is 0. Let's take a look at one where it might not work that nicely. So let's go down and do number 3. Now in this case, it's not going to work out that way. Okay, I can't really factor that, and that's actually a good thing. It's okay. What I'd like it to be, if I worked it out the same way as the one above, is x plus 3 quantity squared, right? Because that's going to give me this middle term of 6x that I really want. But if I multiply out x plus 3 quantity squared, I get x squared plus 6x, which I love, but then I get plus 9, and I really don't want plus 9. I want plus 10. Well, what's to stop me from just saying, oh, I'll add that one there, okay? And that's going to give me my vertex then of -3, 1. Make sense? Let's try another one that's a little bit like that. Let's try number 7. So again, I take my middle term. This kind of relates to completing the square, which you're going to be working on next year. And if I take half the middle term, I would get x plus 5 quantity squared. Well, x plus 5 quantity squared gives me x squared plus 10x, which is what I wanted, plus 25. Well, the 25 isn't good for me. I need 21. So to get that 21, I am going to, you got it, subtract 4. If I subtract 4, that gives me a vertex of -5, -4. Be careful with those subtractions, because remember, it's x minus h squared plus k. So you got to be careful with your signs there. So that one's -5, 4. So I think you are probably good to go on these. Why don't you go ahead and finish those for homework, and I will see you tomorrow.